All right, this is a related rate problem, and the reason you know that is because you're given a rate and you're trying to find a rate. It says find the rate. Okay, so the first thing you want to do is draw a picture. So we have rectangle ABCD. You want to label it correctly, ABCD. Length of 10, I can fill that in. BC is increasing at a rate of 2 meters per second. So I'm going to call BC x. So I know that dx dt, that's the rate at which it's increasing, is equal to 2. Find the rate at which the obtuse angle formed by the diagonals. So let me draw in the diagonals. So here's the obtuse angle right here. So I'll call that theta. So I'm trying to find d theta dt. So we want to find that rate when BC is 4. Now we're not going to use that 4 until later within the problem. So at this point, what you need is an equation involving these two variables. Well, the trick to this problem is we are going to split this up like so. I'm going to draw this in. Now I want you to focus on this triangle. Now since I split it like so, this angle is now theta over 2. Okay, so now I can write an equation involving that triangle because I know that the tangent of theta over 2 is equal to its opposite side. Well, the opposite of that angle is up here, and that's 5 because the original side AB was 10. So 5 over, now how long is this? That's the adjacent. Well, the BC is x, so that little thing I just highlighted in red is x over 2, so x over 2. So here's our equation that involves only theta and x. I'm going to clean it up a little bit. So I've got the tangent of theta over 2 equals 10 over x. Now once you get that equation involving only those two variables, then you differentiate that equation. So the derivative of tangent is secant squared. So it's the secant squared of theta over 2, and then the derivative of the inside, it's 1/2. So it's going to be 1/2 secant squared of theta over 2. And don't forget, you have to tag on your d theta dt equals the right-hand side, the derivative of tan over x is the same as 10 over x, rather, is 10 times x to the negative 1. So power down, negative 1 down, and decrease the power to negative 2. And we got to take on dx dt there. Now once we've taken the derivative of that equation, the rest of it is just subbing in values to solve for d theta dt. This is what we're trying to find. This was the original question, the rate at which that angle's changing. So we have to know everything else. Well, we know what x is because x, it says, was 4. That's from BC equals 4. That was our x. We'll fill that in. So I've got negative 10 x to the negative 2, which is over 4 to the second, which is 16. dx dt was originally given as 2. So there's our right-hand side. Now, we don't know theta, so we're going to have to take a time out here. And I'll draw a little box. We're going to find theta. And in order to find theta, we look at that yellow triangle again. We know that the tan of theta over 2 is 5 over x over 2. So the tan of theta over 2 is equal to 5 over x over 2. And x, remember, was 4. So x over 2 is 2. So in order to find theta, we're going to take the inverse tan of 5/2, and that will give us theta over 2, and then we'll double that angle. So the rest of this little part, it goes to the calculator. Just do the inverse tan of theta over, or 5 over 2, and then that is theta over 2, and then multiply that by 2 to get the angle. Now I'm just going to leave it in radians. You can do it in radians or degrees. You're going to get the same answer. So inverse tan of 5 over 2 times 2 gives you 1.19 radians. So let me come back down to this equation I'm trying to solve. So I have 1/2 secant squared of theta over 2. Wait, one correction. 1.19 radians is theta over 2. That's not theta. We don't need theta at this point because we're working with theta over 2 in our original yellow triangle. So, going back to solving my equation, 1/2 secant squared of theta over 2, so that's 1.19. And d theta dt, which I'm trying to solve for. Okay, so I've almost got it. It's getting a little messy here. Got to squeeze in my equal sign. So in order to solve this equation for d theta dt, first I'll multiply both sides by 2. So I get, let me come over here, I get secant squared of 1.19 d theta dt. Multiply both sides by 2, and I'll get another 2 on this side. So that's 4, cancels into 16, 4 times negative 10. Over 4. And then, to get d theta dt by itself, d theta dt, well, secant is 1 over cosine squared. So if we multiply both sides by the reciprocal of secant squared, that's the same as multiplying both sides by cosine squared, because secant squared is 1 over cosine squared. So if I multiply both sides by cosine squared, go to your calculator, negative 10/4 times cosine squared of 1.19. Multiply that into your calculator and you will have the final answer. I'm just about out of room here. The answer is negative 0.345. And we should put the units on there. That's radians per second. So that's the rate at which that angle is increasing. A little bit of a tricky problem, but just follow the normal pattern for a related rates problem. Write down the rate you are given. There it is, the rate you're trying to find. Write an equation involving only those two variables, which we came up with. Right here, you take the derivative of that equation, which is right here, and then you sub in all your known values to solve for what you're trying to find, which is d theta dt. So it follows the normal pattern. Good luck.